Welcome. In this video I'm going to show you how you can perform a McNemar test as a post-hoc test for the Bhapkar test using Python 3 and specifically JupyterLab. So after a Bhapkar test you might want to know which category saw a change in proportions. If you want to know how to perform the Bhapkar test with Python, I have a separate video on that. To perform this so-called post-hoc test, a McNemar test might be an option. I haven't found any package that can do this. I found packages that can do a McNemar test, but that's just for a single square table. So I'll have to adjust it a little bit myself. To show an example, I'll have some data, and that data I'll load as a pandas DataFrame. So I will first need to install pandas, which I've already done. If you've never installed a package before, you can often use exclamation sign pip install and then the name of the package without this hashtag. Then I need to load the package, import pandas as PD. SPD is just to abbreviate it. And then I can use the read CSV function to load my nominal paired data. The head function here will simply show me the first 5 records. Now this was before versus after, so people could choose something before between brands A, B and C, and then after seeing commercials of them perhaps choose which one they preferred after that, brands A, B or C. We begin with creating a cross table, so cross step. And then this shows us that, for example, 3 people had originally had brand B and then they switched to brand A. Now for the pairwise comparisons we need a few basic items. The sum of the columns, so these basically. The sum of the rows, so horizontally. The total number of cases, which is actually the sum of all of them. And the number of categories, which should be the same for the number of columns and rows, and in this case should be 3. So I can do that simply by sum most of them. Sum will, from a cross table, will simply give me the columns totals. If you put axis equals 1, it will do the row totals. The sum of all my column totals is the grand total. I could have also done the sum of R, which is the sum of the row totals. The k is the len function, then I get how long that particular list is, and in this case that should return to me 3. So let's load that. We also need 2 functions from the SciPy stats package to find the p-values, that's the chi-square and the binomial test, because depending on how many data points we have, we either perform the exact binomial test or do an approximate chi-square version. Now for each brand, what we actually do is we create a 2x2 table, and on that we can then perform that McNemar test. So we select, for example, brand A, and then we get before A and not before was not brand A, versus after was brand A and after was not brand A. And like I said, we can then perform a chi-square test on that table by simply looking at the diagonal b minus c, square the result, and divide it over the sum of those two. The degrees of freedom that you always need for a chi-square test is simply 1, always, for this test. If we don't have enough data points, if b plus c is less than 25, at least that's the criteria according to Wikipedia, and there are a few other sources that have something similar, then we'll use the exact binomial test, and that's simply in that binomial test function, so you don't have to remember that entire formula. So I can do all this code by actually doing the following. I create a pandas data frame, an empty one with just some column headings. I set my degrees of freedom, of course, to 1, and then I go for each category, so for each I in range k, I'll create my A, B, C, and D that I showed, sorry for the scrolling up here, so that's A, B, C, and D. And I can simply get those from the table by selecting the A is then, of course, the number of people who had before and after I. B is then the row total, actually minus I, minus A, so that's the people who did not choose it before, I think, and C was after. And then whatever is left is then simply everyone minus A, B, and C. I can then calculate that chi-square value and then the p-value using that chi-square from SciPy-Stats. Adding the Bonferroni adjustment, because we're doing multiple tests, we want to adjust for multiple testing, because otherwise we get too many, we have a big risk of making a type 2 error, I think it is. So what we'll do is we simply use the Bonferroni adjustment, and we simply multiply by the number of tests that we're doing, which is the same as the number of categories that we have, so simply times k. That might then become bigger than 1, which is impossible for a p-value, so then we simply set it to 1. We do the same for the binomial exact test, and then we simply add everything in our pandas data frame. And that should give us then a nice little result. And then that's the new row, and that gets added every time. So the final result looks then something like this. So for brand A, we have an N of 25. So what we can do is it's less than 25, it's 18, sorry. So we look here actually. And then we actually use the exact adjusted one, so because it's less than 25, and we see the 0.0226. That's below the usual threshold of 0.05, so there was a significant change in before and after for brand A. For brand B there was no significant one, that's this one, and for brand C it is significant, and in this case it doesn't really matter if you use the exact or the approximate version. I made a little function out of all of this so that I didn't have to repeat everything every time. So here's that entire, well, it's basically the same code but now slightly adjusted, so I can just put it in as a function. I'll leave a link to this Jupyter notebook in the description of the video, so if you want to download it and look at the code yourself, that's no problem. Thank you for watching. I hope this was helpful.